If something turns from science fiction to reality, that's usually good news. In this case, not so much. The term termination shock has jumped from science fiction into the news. The reason is that some climate scientists have argued that the recent increase in the pace of global warming is due to cleaning up the air. I have a summary. The term termination shock was popularized by Neil Stephenson a few years ago, but it's been used in the climate change literature for 20 years to refer to the sudden end of geoengineering. Suppose we spray particles into the upper atmosphere to block sunlight. This could reduce warming by a few degrees, so it'd be substantial. But then we need to continue doing this, or all that warming is going to come back very suddenly as the particles are washed out of the atmosphere. This is the termination shock. It's one of the reasons why most people don't like the idea of reducing warming by geoengineering. That'd require reliable and coordinated planning, and if we were any good at that, we wouldn't be here in 2025 talking about geoengineering, would we? Personally, I'm convinced we'll do it, but I'll get to this. Let me first tell you why the termination shock has crept into the headlines more recently. It's because we've been cleaning up air pollution, and the question is how much that contributes to the warming we're seeing. The issue is burning fossil fuels doesn't just release greenhouse gases. It also releases sulfur dioxide and other chemicals, which form tiny particles called aerosols that can brighten clouds and reflect sunlight. That cools the surface of our planet. Indeed, it's why climate scientists think between 1940 and 1970 or so, global temperatures were pretty much steady or maybe even slightly decreased. That was all the air pollution. But in contrast to carbon dioxide, air pollution directly reduces people's quality of life. And so in the past decade, especially China has made a lot of effort to reduce air pollution from burning coal. Another much discussed turning point was that the International Maritime Organization has much tightened the regulations on ship emissions. The result is that our planet now absorbs more energy from the sun, especially over the oceans. The climate scientist James Hansen has called this a Faustian bargain. For decades, we emitted both long-lived carbon dioxide that warms and short-lived aerosols that cool. But like in Goethe's play, eventually there's a price to pay, and that's due when we clean up the aerosols. In a 2013 essay, Hansen wrote that then the devil's payment will be extracted from humanity via increased global warming. And would you know it, in the past years, temperatures have indeed increased more than most climate scientists thought they would, supporting Hansen's warning. Or maybe temperatures didn't increase and it's just a temporary fluctuation and temperatures will go down again. It'd be good to know, wouldn't it? After all, Faust did go to heaven eventually, after helping the devil to introduce paper money. It all makes sense now. Well, this is why the question of just what aerosols do to average temperatures has become so controversial. And once again, the question comes down to clouds. If you ever want to make a climate scientist cry, ask them about clouds. They have no idea what's going on with the clouds. Air pollution aids the formation of clouds, okay, but the effect on temperatures depends on what type of clouds form where, and that is far from clear. That's why we have one camp of scientists which argues that aerosol reduction explains the recent spike. The authors of one paper, for example, described the ship emission rules change as an inadvertent geoengineering termination shock. And can you blame the media for picking it up? James Hansen and co-authors likewise argue that aerosol masking has been underestimated and that recent reductions helped push record warmth. But most studies have found that the effect is overall small, 0.05 degrees or below, so not even a 1/10 of a degree on average, though it might be larger regionally. For example, the reduction in air pollution over big Chinese cities might have increased heat wave temperatures there by 1/2 degree. The ship emission reduction plausibly also had a local effect directly over the shipping routes. To me, it seems that termination shock is somewhat of an overstatement. It's more a shockino than a shock. But I also think that this isn't really the relevant part of this discussion. The more relevant part is no one has any idea what the hell is going on and what the consequences will be of our fiddling with the climate. We've seen temperatures over Europe increase much faster than elsewhere in the world. No one predicted this. The Arctic tundra has turned into a net emitter of carbon dioxide rather than an absorber. No one predicted this. The Gulf of Panama seasonal upwelling failed in early 2025 for the first time in the 40-year record. No one predicted this. This, in my mind, is the problem. We're changing our environment quickly and we don't know what we're doing, which is why I strongly suspect that many nations will soon take to geoengineering as a local countermeasure. Not the global atmospheric injection. No, they'll try to regionally reduce temperatures by spraying something. Give it a decade and the chemtrail conspiracy theorists might actually be onto something. If you see me outside with a ladder and a measuring spoon, I'm calibrating, not marinating. Academic research is deteriorating at an increasing pace. We've talked several times previously about how organized fraud is spreading in science, and today I have some recent stories that document that this is becoming a global problem. Before I talk about fraud, I have to tell you this amazing story of a particle physicist in CERN's ATLAS collaboration. She works in Chile at the University of Tarapacá, which has a bonus program for publishing papers in high-impact journals. Well, the papers of the ATLAS collaboration pretty much all get published in high-impact journals. They also each have like 3,000 or 4,000 authors, but rules are rules, and so this particle physicist made about $320,000 in publication bonus over 8 months. You can't make this up. Okay, now let's talk about the spread of paper mills and other unethical publication practices. Paper mills are networks of brokers that sell authorships on scientific scam papers or citations. These scam papers are increasingly written by AI. This problem first emerged in China and India, but in the past years, it's been moving west. Just a few weeks ago, a particularly large European paper mill network was busted, which operated out of Ukraine. It had reportedly sold more than 1,500 papers from 2017 to 2025, involving more than 4,500 authors. This comes just a few months after a former student of the University of Manchester was found running a paper mill, and 2 Hungarian postdocs were found to have published with a paper mill, though they claim it was an accident. Another stunning incident happened in Poland, so you can basically track on a map how these practices are moving west. The Polish story is remarkable because the person who's been accused of working with paper mills was vice rector for science at a Polish university and also head of Poland's top science policy council. At least 3 of his papers have since been retracted, and he resigned from his vice rector post. He denies wrongdoing. But this story pales in comparison to what happened in Spain, where the rector of the University of Salamanca had a whopping 75 papers retracted. This came after an investigation found he ran what the report calls a publication and citation factory. He allegedly pressured collaborators to cite him excessively, organized conferences whose proceedings he controlled, and exploited them to boost his citation counts, helping him appear among the world's most cited researchers. He denies wrongdoing. These activities are spreading because the people engaged in it are making money, and it isn't per se illegal. illegal. There's no law forbidding anyone to sell or buy authorships on papers, or for that matter, to pressure colleagues to cite them. It would become a criminal offense if there was, say, public funding spent on it, but mostly these people pay it privately. This makes it a fairly low-risk activity. The biggest risk is that other people find out they had their name on scam papers. But the way that things are going, this is becoming so common that a few years down the line, no one will exactly remember who did what. But yes, there are also cases in which science funding is illegally used. A recent investigation by Digital Science, for example, revealed that a total of about $6.5 million in research funding in countries including the US, Japan, Ireland, and France went to a non-existent research network. This was run by people who simply managed to put the name of the network on papers as an affiliation and then applied for money with the supposed publications. And in Romania, 4 university staff members have been accused of funneling 2.5 million of EU money into their own pockets, among other things, with fake travel claims. I think what we're seeing here is the slow unraveling of academic research. This is an incredibly odd system that we have built globally in the past 50 years, and it's becoming increasingly clear that it's fundamentally broken. People from both within and outside academia have been drawing attention to the problems with the incentive structure for decades, but this problem has just become worse. It's become worse, I believe, because we're much stronger globally connected now, and we have more ways to quantify research output, all of which creates possibilities to game the system better than ever before. I know that most of you think I'm crazy when I say academia's falling apart, but wait a few years, and I think you'll see it too. Until then, stay tuned and don't forget to subscribe for more updates on the demise of Western civilization. I deny any wrongdoing. Physicists have finally found a way to test whether the vacuum is actually made of particles. This is called the Unruh effect, and observing it would be a deep insight into particle physics and relativity. I myself don't believe this effect is real, which for most physicists amount to blasphemy, so I certainly hope it'll be tested soon. Let's have a look. Vacuum. What is it? In quantum physics, vacuum is the absence of particles, but that's only true for some observers, namely those who move at a constant velocity. As per Unruh pointed out in the 1970s, if you don't move at a constant velocity, then the vacuum seems to fall apart into particles. Technically, the reason for this is that what we mean by a particle depends on how we move. That is, the notion of a particle itself becomes relative in Einstein's relativity. Where does the energy for these particles come from? Well, to accelerate, you need energy, so there always must be an energy source. But the consequence is that an accelerated observer of any sort should witness particles at a temperature that's related to the acceleration. The higher the acceleration, the higher the temperature. That is the average energy of the particles. This is now called the Unruh effect, and if you ever feel like your life's falling apart, maybe you're just accelerating. I believe this effect doesn't exist because I think a particle either is a particle or not. Its existence doesn't depend on how some observer moves. Most physicists, however, think that this effect is real, mostly because it can be used to explain why black holes evaporate. You see, you can say that if an observer hovers near a black hole horizon, not directly at the horizon but nearby, then they must be accelerated, otherwise they'd fall in. But according to the Unruh effect, that means the observer sees particles. So the black hole radiates. That sounds superficially plausible, but I'd argue that these two effects are actually mathematically very different. In any case, though, I've been waiting for 30 years to see an experimental test of the Unruh effect. Because while it's in practice impossible to measure whether black holes emit radiation, the temperature is far too low to be measurable, it should be possible to measure the UNRU radiation. The problem is that the temperature of this UNRU radiation is very low. There have been many proposals for how to test it, but it's remained out of experimental reach, and this finally brings me to the new paper. The authors of the new paper propose to use 2 layers of superconducting material separated by insulators in a ring, which you see here in this figure. In these rings, they have quasi-particles called fluxons and antifluxons. Quasi-particles are basically collective motion, similar to waves in water. These quasi-particles are coupled across the 2 layers. Then they put a current on each of the superconductors, and that puts the quasi-particles into a circular motion. Round and round they go, both together. The larger the current, the higher the acceleration. However, this doesn't continue forever. Eventually, this pair breaks, and this leads to a measurable jump in the voltage. They calculate that the current at which the pair breaks depends on the charge fluctuations in the superconductors, and these fluctuations are what they interpret as the UNRU particles. So the logic is that they infer the presence of the UNRU particles from how easily the quasi-particle pair breaks, which they can measure. The nice thing about this is that the acceleration one can reach this way is remarkably high, simply because the rings are so small. The problem with this idea is that, well, it doesn't happen in vacuum. This is clearly an in-medium effect, whereas the UNRU effect is all about the properties of the vacuum. At best, I think one could interpret such an effect as an analogy to the UNRU effect. At least I wouldn't accept it as proof for the UNRU effect. So far, the best idea to test this effect that I know of comes from trying to accelerate electrons with a very big laser. However, the currently existing lasers aren't strong enough to accelerate the electrons enough for this to be measurable. I give this paper a 2 out of 10 on the bullshit meter. I think it's a good proposal and an important topic, but they should have stressed the shortcomings with the interpretation more clearly. You're not going to test the vacuum effect in medium. If you ever need to explain the UNRU effect at a party, just say vacuum isn't empty, it's observer dependent, and then watch everyone accelerate away from you. Thanks for watching. See you tomorrow.